Okay, so in this video I'm going to have a look at the Leaving Cert High Level Paper 1 for 2017, and I'm going to have a look at question 5. So this question involves functions, and we're given a function here, this cubic function here. We're asked to show that x is equal to minus 3 is a root. So in order to do that, all you've got to do is substitute the minus 3 in for x and you should get 0. In other words, f of minus 3 should give us 0. So I started it here. I put the minus 3 in for x here. Let's just see what we get. So here we have a minus 3 cubed, so that's going to give us a minus anyway, and then multiplied by a plus. So our answer is going to be minus, and this is actually 54. Here we've got a minus squared, so that's a plus times a plus, so that's going to be plus, and that gives us 45. Minus times minus is plus, 3 4s 12, minus 3 should be equal to 0. We get minus 54 minus 3 is minus 57. 45 plus 12 is plus 57, equal to 0. So minus 57 plus 57 gives us 0. So that means 0 is equal to 0. That means when we substitute minus 3 in for x, we get 0. So that shows us that minus 3, x equal to minus 3 is a root. This is where the graph cuts the x-axis. The graph will look something like this, and if this is our x-axis here, one of these points here on the x-axis is minus 3. Okay, so that means x is equal to minus 3 is a root. So that's our proof there. So that's our answer really. All of this is our answer here. Okay, so the next part of our question requires us to find the other two roots. So this is a cubic function, so there are at least, or at most, 3 roots. We found one of them here anyway. So if x is equal to minus 3 as a root, by the factor theorem, x plus 3 then is a factor of our f of x. So that means if you divide x plus 3 into our function, it should divide in evenly, without any remainder. So we're going to do that in order to find the other roots, the other factors first and then the other roots. So we're going to take the x plus 3 and we're going to divide that into our function. So our function is 2x cubed plus 5x squared minus 4x and minus 3. So let's start then. X into 2x cubed. Well, 2x cubed is 2 times x times x times x. We've got to divide that by x. So everything on the top is multiplied, so we can just divide the top by the bottom, and we get 2 times x, which is 2x squared. So our answer here is 2x squared. Okay, so we're going to take this 2x squared, we're going to multiply it by these two terms here, put our answer underneath here. So 2x squared times x is 2x cubed, which is the same as this term here, which is what you want. If you don't get the same thing here, you've done something wrong. Okay, so 2x squared times plus 3 is plus 6x squared. Put a line underneath and subtract. So we're going to subtract these two terms. So minus 2x cubed plus 2x cubed gives us 0. Minus times plus here is minus. So we have 5x squared plus 5x squared minus 6x squared. That gives me minus x squared. We're then going to take this term here, bring it down. So that's a minus 4x. And we start again. X into minus 4x squared is minus x. So minus times plus is minus. X times x, x squared. Minus times plus is minus. 3 times x is 3x. Put a line underneath, same thing again, subtract. Okay, so minus times minus is plus, so we have a plus x squared and minus x squared. They should cancel. You should get 0 here. This minus times this minus is plus, so we have plus 3x minus 4x. That gives us minus x here. Okay, so now we're going to take our last term here, bring it down, do the same again. So we have a minus 3 here. Take this x here, divide it into this minus x. So plus into minus is minus, x into x is 1. take the plus 1, or sorry, this minus 1 here, multiply it by these two, put our answer under here. The procedure just keeps repeating over and over again. So minus 1 times x is minus x. You would expect that. Minus times plus is minus. 3 times 1, 3. So you can see what's going to happen here. When we subtract these two here, this is going to cancel, this is going to cancel, we get 0. So you would expect 0 remainder because we were told that x plus 3 is a factor. Well, we were told that x equal to minus 3 is a root, so x plus 3 must be a factor, must divide in evenly. So this is our other factor here. So in other words, if this is one factor, this is our other factor here. So what does that mean? That means when we take the x plus 3, so our function f of x is just equal to the x plus 3 multiplied by the quadratic, which was 2x squared plus minus we have a minus here, minus x minus 1. Okay, so when we multiply this factor which we just determined up here by the x plus 3, that will give us our original function. However, we can take this quadratic trinomial here and factorize it further to give us our two simplest roots, our two simplest factors, and from that we can find our roots. So this will be 2x times x. Here we have a 1, so that'll be 1 times 1. This is a minus, so it's going to be plus times minus, or minus times plus. I'm going to put the minus here and the plus here, so that actually works. 2x times x is 2x squared, 1 times minus 1 is minus 1, and when we take the remaining 2, we do get minus x here, so that's fine. So that really means then that if we want to find our roots, then all of these, this x plus 3, 2x plus 1, and the x minus 1 multiplied together should give us 0 for our three roots. Now, in order for that to happen, that means x plus 3 must be equal to 0, or 2x plus 1 must be equal to 0, or x minus 1 must be equal to 0. So that finally will give me x is equal to minus 3, which we were told in the question anyway. Here we end up with x is equal to minus 1 over 2, and here we end up with x is equal to 1. So these are all our roots. So in other words, our function will look something like this, with our x-axis here, and this one here is going to be our minus 3, 0. This one here is going to be the minus half, 0. Remember, y is 0. And this one here, where it cuts the y-axis here, that's going to be x is equal to 1, so that's going to be 1, 0 here. So our y-axis will be somewhere down along here, I think. Okay, that's fine. So let's have a look at the next part of our question then. In this particular question, we've got to find the coordinates of the local maximum point and the local minimum point of the function. Okay, so in order to do that, we're looking at differentiation. So let's have a look. Our function was f of x is equal to 2x cubed plus 5x squared minus 4x minus 3. So the function that we're looking at actually looks like this. This is the actual function here, and we can see these are our three roots. Our minus 3, this is minus half, and this is 1 here. And what we're looking for is this point up here and this point down here. So in order to do that, what we do is we differentiate this function, and what that does for us is it gives us the slope of the tangent at any point x. The slope of the tangent at any point x. So if our function is like this, we can have an infinite number of tangents. So if we want this tangent, the slope of this tangent here, all we've got to do is differentiate the function, put that x value in, whatever it is on the x-axis, into our differentiated function, and that will give us the slope of this line here. So let's just differentiate it first anyway. F dash x, so that's going to be 6x squared plus 10x minus 4. Okay, so we want at our maximum point here and our minimum point here, the tangents will be straight across like this. They will be horizontal, so they will have zero slope. And there are only 2 points on this function that have tangents that have zero slope. One tangent here and one tangent here. So in other words, if we let this equal to 0, if we take our 6x squared plus 10x minus 4, which is our slope of any tangent, if we let that equal to 0, that will give us two x values, the two x values where the slope is 0. So let's just solve this then. Well, initially what we can do here is we can divide across by 2. That'll give us 3x squared plus 5x minus 2 equal to 0. Divide by 2, divide by 2, divide by 2, and divide by 2. Next thing we can do is just factorize this. So we have 3x times x. We have 2 times 1, or 1 times 2. I think that works there. It's all, let me see, it is, let's see, I think if we put a minus here and a plus here, it should work. So 3x times x is 3x squared minus 2 minus 1x plus 6x will give us the 5x. Yes, that's okay. So that means that 3x minus 1 is equal to 0, or the x plus 2 is equal to 0. So that will finally give me x is equal to 1/3 or minus 2. X is equal to 1/3 or minus 2. So in other words, this is our minimum in this particular case. So presumably this is 1/3 here, and minus 2 is the other value we got, and we can see that is right on the minus 2 here. That's our maximum there. So they give us our x and y values for, or sorry, it gives our x values for the minimum and maximum. In order to find our y values, we've got to stick them back into our original function to find the y values. So let's just have a look at that. So we have, let's take x is equal to 1/3 first. So we've got to stick that into our original function to find what y value that will give us. So I'll just write it out as 2 times the x is 1/3, and that's cubed, plus 5 times 1/3, and that's squared, minus 4 times 1/3, and that's the power of 1, and then minus 3. If you do that all out, what you actually get is minus 100 over 27. Okay, you can do the calculations yourself. Do it if you're actually doing this in an exam, you know, do it line by line by line, but this is what you should end up with. The next one is x is equal to minus 2. So what's the y value for this one? Well, let's see, we've got 2 times minus 2 cubed plus 5 times minus 2 squared minus 4 times minus 2 minus 3. When you actually do that, and again in an exam, or if you're doing this out yourself, you know, do it out line by line rather than trying to do it all at once, but you actually get 9. So our two points are going to be 1/3 and then minus 100 over 27. That's 1 point, and the other one then is going to be minus 2, 9. So we can see from this diagram here, we got our minus 2, 9 is our maximum, and the other one here is our minimum. However, you won't have that facility in an exam, so you're going to have to check which one is the minimum, which one is the maximum. Now it probably looks fairly obvious anyway, which one is going to be which, but to do it out formally, what you need to do is you differentiate your function again. So I just write out our differentiated function initially was 6x squared plus 10x minus 4. So you got to differentiate this again. This is our differentiated function, so we got to do that again. Then differentiate a second time, you get 12x plus 10. 12x plus 10. And what you do then is you take the x is equal to, you take your two, we'll take this one first. So we'll go with the 1/3 first of all, okay? So you take that and you put it into this function. So in other words, it's 12 times 1/3 plus 10. When you do that, you get 14. Now 14 is positive. It's a positive number, so that implies that we're looking at a minimum. A minimum at x is equal to 1/3. If we take the x is equal to -2, this point here, we do the same again. Take the 12, put in the -2 plus 10. In this particular case, we get -14. So this is negative. So it's negative. That implies that we're talking about a maximum at x is equal to -2. So this here is our maximum, and this here is our minimum point here. And that's it really. We can see that that is actually the case on our graph here. Okay, so that's it. Let's have a look at the next question. It's down here. Let me just move it up a little bit. Okay, so in this particular case we're told that f of x plus some number, so we're adding some constant to our function, and we want that particular function here, this function f of x plus a, to only have one real root. Find the range of possible values for a. So let me just explain what we need to do here. We can see with our original function here, it crosses the x-axis in 3 places. Here, here, and here. -3, -0.5, and 1. Now, so it has 3 roots. The only way we can make this function have one root, well, there are 2 ways of doing it. We can move the entire graph vertically upwards so that our minimum point here reaches the x-axis and goes just beyond it. At that point, we will end up with a graph where only this arm here will cross the x-axis. So these 2 will disappear. This peak here will be up here somewhere. So what distance would we have to move the graph vertically upwards in order to bring this minimum point past the x-axis? Well, the distance from here to here is 100 over 27. Remember this point here is 1/3 and then minus 100 over 27. So 100 over 27, 100 divided by 27 is roughly 3.7. So in other words, this point here is 1/3 minus 3.7. So if we added 3.7 to our function, to our original function, that would bring the graph up by 3.7. So if we just look at that, so if I take my function here, this is the function here. I'll just key in here plus, let's say 100 divided by 27 and see what happens. So you can see what happened here. The entire graph moved up by roughly 3.7. We still have a root. It's just touching the x-axis there. So we now have 2 roots, if you like. We have this root here, and we have actually repeated roots here just on the x-axis. So anything greater than this 100 over 27 here will bring this point here above the x-axis, and we'll only end up with 1 root. So our answer really then, or one part of our answer, is that a has to be greater than 100 over 27. Okay, so what's our other option then? Let's have a look. Let's go back to our graph again. Let me just go back here again and take that out. So if I remove that, let's see. Let's see if I can just delete this. So what we're going to do here then is go back to our original graph, So this is what our graph looked like originally. Now you can see here that this point here is minus 2, 9. What we can also do is just take our original function and bring the whole graph down 9 places. So in other words, if we subtracted 9 from our function, it should bring the entire graph down to here. So let me just see if I can do that here. So we'll put in a minus 9 here, and you can see the entire graph has moved down. So at this stage we still have a root here, we have a repeated root here, but we have another root here. So anything smaller than that 9 then, anything less than minus 9 in fact, if we put in let's say a minus 10 or a minus 11 or a minus 12, this maximum point here would end up down here, which would mean we would only have one arm. This right arm would be the only part of the graph crossing the x-axis and giving us only one real root. So in other words, the other option for A here would be that A would be less than minus 9. So there are two possibilities, the range of possibilities. So we can write it like, you can leave it like that, or you can write it like this. A has to be greater than 100 over 27 or less than minus 9. Okay, so I think that's just about it for question 5.